Hello, Algebra Honors. We're going to have a quick warm-up for our exponents and radicals unit. And we're going to be simplifying radical expressions or solving radical equations, depending on whether we have an equation or an expression that we start with. So if we simplify the following radical expressions, we want to make sure that we follow all of our rules. Our answers have to have no radicals that could be simplified further. We can't have a fraction in a radical. We can't have a radical in a denominator. And that should get us going. So if I want to solve this equation, I am solving for r. So the first thing I'm going to do is get my radical part isolated. So I'm going to divide each side by -5, excuse me. And so I have the square root of 4r plus 5. That is all under the same square root bar. That equals +5. I'm going to square each side, and remember when we square something, we're just undoing the square root. So I'm left with 4r plus 5 equals 25. Subtract 5 from each side, and I have 4r equals 20, and r equals 5. Okay, I want to double check and make sure that works. So 20 plus 5 is 25, and the square root of 25 is 5. 5 times -5 is -25, so that worked. Okay, you do want to double check and make sure that you don't have any extraneous solutions here. Number 2, I already have that radical isolated, so I'm going to square each side. So I have 16 equals 5x minus 4. Add 4 to each side, I have 20 equals 5x, and then x equals 4. If I plug it back in, 20 minus 4 is 16, and the square root of 16 really is +4, so that's true. Okay, number 3, right here. This one is just an expression that I can simplify, right? So I have the same exact radicand, meaning AB underneath the radical. I have the same index. These are square roots. So I have 5 roots of AB, and then I have 6 more of them, so I have a total of 11 roots of AB. Okay. 12 roots of 2x minus 3 roots of 2x, same exact radicand, same exact index, so I have 12 of them, and I take away 3, I'm left with 9 of them. And of them, those happen to be square root of 2x. 5 times the square root of 6 plus 6 times the square root of 2. I cannot simplify square root of 6 in any way that makes these have the same radicand. So I do know that square root of 6 is the same thing as square root of 3 times square root of 2, but that doesn't help me. In the same way as if I had like AB plus A, I see there's an A in both of those terms, but I can't combine those, right? Because they are not like terms. So here, that's it. We're done. All right. Multiplying. So I have 4 times the square root of 3 times 3 times the square root of 6. So you know with commutative property, I can rewrite that as 4 times 3 times the square root of 3 times the square root of 6. And then with my product rule, you know that I can rewrite that as 12 times the square root of 3 times 6 under the same radical, which is 18. But I know that that is 12 times the square root of 9 times 2. Square root of 9 is 3, so I'm going to have 36 roots of 2. Okay. 2 times the square root of 5 squared. I'm going to distribute that outer 2 to everything. So I now have 2 squared times the square root of 5 squared. Okay, and squared undoes square root, so I have 2 squared times 5, so I have 4 times 5, which equals 20. All right. Square root of 3 times all of this. So this is going to be distributive property. I'm distributing over addition because I'm adding terms inside those parentheses. So I have the square root of 3 times 5 times the square root of 2. I'm going to rearrange and make that be the square root of, it's going to be 5 times the square root of 3 times 2 in the same house, plus the square root of 3 times the square root of 3 is going to be the square root of 3 squared, right? Because 3 times 3 is 3 squared. So I have 5 times the square root of 6 plus just 3. The square root and the square cancel out, so I just have 5 roots of 6 plus 3. Square root of 6 times 7 times the square root of 3. I know that's 7 times the square root of 18, right? Because square root of 3 times square root of 6 is 18. Square root of 18 right there. Okay, square root of 6 times 6 is going to be 6 roots of 6. And I know that this is 7 times the square root of 9 times 2 plus 6 times the square root of 6. And so that's 21 roots of 2 plus 6 roots of 6. That's my answer. Okay, square root of 2 times square root of 32 plus square root of 2 times square root of 10. So I have square root of 64 plus square root of 20. I have 8 plus 2 roots of 5. Excuse me. Okay, square root of 3y times the square root of 12y cubed. I'm going to put everything under the same radical, so I have the square root of 36y to the 4th, and those are perfect squares each. So this is going to be 6y squared as my answer. And here I'm going to use the product rule and put these guys all under the same house. So I have the square root of 40, x to the 9, and then I'm going to break this up. So I know that this is 4 times 10 times x to the 8 times x. And I'm breaking that up because I can see perfect squares now. So I have 2x to the 4th. Remember, we say x to the 8th divided by 2. 8 divided by 2 is 4. So I took care of my 4 and my x to the 8th. And it's still times the square root of 10x. And that's my answer. Great. Thank you for watching.